Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 7 to the power of x plus 8 is equal to 8 to the power of x plus 7. So now the first thing I'm going to do is I'm going to use an important exponential property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So I'm going to first use this property on 7 to the power of x plus 8. So in this case, a is equal to 7, m is equal to x, and n is equal to 8. So I have a to the power of m, so 7 to the power of x, times a to the power of n, so 7 to the power of 8. And this is equal to a to the power of x plus 7. Now I'm going to use this property on a to the power of x plus 7. So in this case, a is equal to 8, m is equal to x, and n is equal to 7. So now I have 7 to the power of x times 7 to the power of 8 is equal to 8 to the power of x times 8 to the power of 7. Now I'm going to divide both sides by 7 to the power of 8 and 8 to the power of x. So then these two cancel out. So now I have 7 to the power of x over 8 to the power of x is equal to, on this side, these two cancel out. So 8 to the power of 7 over 7 to the power of 8. Now if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 7 to the power of x over 8 to the power of x, that's going to equal 7 over 8 to the power of x. Now this is equal to still 8 to the power of 7 over 7 to the power of 8. Now I'm going to go ahead and take the log on both sides. So now I have log 7 over 8 to the power of x is equal to log 8 to the power of 7 over 7 to the power of 8. Now if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. So in this case, I have log 7 over 8 to the power of x. I can move this exponent to the front. So now I have x times log 7 over 8 is equal to log 8 to the power of 7 over 7 to the power of 8. Now, if I have something in the form log a over b, this is the same thing as log a minus log b. So in this case, log 7 over 8, this is going to equal log 7 minus log 8. And log 8 to the power of 7 over 7 to the power of 8 is going to equal log 8 to the power of 7 minus log 7 to the power of 8. Ooh, and sorry, I didn't mean to put this log. That's not supposed to be there. So now if I have something in the form log a to the power of b, this is equal to, again, I can move this exponent b to the front, so it's b times log a. So for log a to the power of 7, I can move the 7 to the front, and same with log 7 to the power of 8. I can move the a to the front. So now I have x times log 7 minus log 8, which is equal to 7 log 8 minus 8 times log 7. Now I'm going to divide both sides by log 7 minus log 8. So then these two cancel out, and I would be left with x is equal to 7 times log 8 minus 8 times log 7, over log 7 minus log 8. All right, so now we have x equals 7 times log 8 minus 8 times log 7 over log 7 minus log 8. So now if you plug in log 7 into a calculator, you get that log 7 here, this is equal to 0.8451 approximately. So I can use the sign for approximately. And now log 8, this is approximately equal to 0.9031. So now if I plug these values into our original equation was x is equal to 7 times log 8 minus 8 times log 7 divided by log 7 minus log 8. So now, if we plug these values in, first off, we have 7 times log 8. So log 8 is approximately equal to 0.9031. So I have x is equal to 7 times 0.9031. And I have this minus 8 times log 7 is 0.8451. So I have 8 times 0.8451. And now we're dividing this by log 7 minus log 8. So this would be 0.8451 minus 0.9031. So now 7 times 0.9031 is approximately 6.3297 minus now 8 times 0.8451 is 6.7608. Now I'm dividing this by negative 0.0580. And now if I subtracted these two, I get negative 0.4399 over negative 0.0580. So then this would equal 7.5707.